Welcome to a series of lessons on determinants of matrices, and we are going to go through the formal definition of determinant of matrix, and then we'll take each line of definition one after the other and then talk about them. So the determinant of a matrix, so if I have a matrix A being an n by n matrix, so the first thing is that before you can find a determinant of a matrix, it should be a square matrix, okay? The determinant of A, denoted as that of A, is calculated by picking a row, just picking one particular row that you are interested in, and taking the product of each entry in that row with its cofactor, and then adding these products together. So, one other thing we'll do again will be to go through the definition of a cofactor and then maybe other definitions as well. Okay. So, the definition, the first part is taking a particular row and then expanding it like that, or maybe you're going to take a particular column. I know the J stands for columns and then the I stands for rows, but in this case, when we start taking an example, you understand why the J part is the row and then the I part is the column. Now the claim here is that the determinant of a 1 by 1 matrix that is a constant value is just the value A, or whatever value you had there. And the determinant of a 2 by 2 matrix is given by the product of the diagonals minus the product of the other entries. Okay, so I'll go through the whole process why this claim is true using this definition in another video, but for now let's just take it that the definition of the determinant of a 2 by 2 matrix is this definition given here. Okay, now let's pick an example and then go through. So the definition saying that determinant of a 2 by 2 matrix is just the product of the diagonal entries and then minus the product of the other entries as well. So what I'm going to do here, I'm going to pick the diagonals, which is 2 and 6, and then I multiply them. So I'm going to have 2 by 6 and then minus -1 times 4, and this is going to be 8 minus 4, and that is 8 plus 4, which is 12, right? So determinant of this matrix here, which is a 2 by 2 matrix, is actually 12, right? So we're gonna look at the determinant of 2 times 6 is actually 12. I'm sorry about this part. I don't know why, but I made that mistake there. 2 times 6 is 12, and then minus 4, and that is going to give me 12 plus 4, so that's going to be 18. Okay, now on the other hand, I can also pick another example here, which is the matrix A being given by 2 1 and then 1 3. So with this, if I find a determinant of A, that's going to be 2 times 3, which is 6, minus 1 times 1, which is 1, and when you subtract these, you're going to get 5. All right, so that's the quick introduction to determinant of a matrix, and this is the definition for finding the determinant of a 2 by 2 matrix. And trust me, I'm going to go through the other definition, which we'll talk about determinant of big matrix. Okay, all right, so see you in our next lesson.